Welcome to Tiny Science Tutorials. Today, we're diving into the mesmerizing world of quantum entanglement. At the heart of quantum mechanics lies a phenomenon known as quantum entanglement. When two particles become entangled, their fates become interconnected, regardless of the distance between them. Back in 1935, renowned physicists Albert Einstein, Boris Podolsky, and Nathan Rosen discussed this strange property in a famous thought experiment known as the EPR Paradox. The EPR Paradox raised puzzling questions about the behavior of entangled particles, challenging the principles of classical physics. Fast forward to the 1960s and 70s, groundbreaking experiments conducted by John Bell revealed that quantum entanglement defied classical physics, and Einstein's reservations were seemingly confirmed. Imagine spinning two entangled coins and then separating them by significant distances. Whenever you measure the spin of one coin, its entangled partner instantly assumes the opposite spin, as if they are communicating faster than the speed of light. This bizarre and counterintuitive behavior of entangled particles has been experimentally verified, even when entangling particles separated by significant distances. Quantum entanglement holds tremendous promise for future technologies. It's at the heart of quantum computing and quantum communication, which could revolutionize how we process information and secure our communications. Though quantum entanglement challenges our classical understanding of reality, it offers a glimpse into the astonishing and wondrous world of quantum physics. We hope you enjoyed this brief exploration. Stay curious and keep learning.